Last one, the intent here is not to solve all of these with you. There'll be a key post online that has all the answers, but the idea here is to maybe walk you through a couple sample problems, and that should hopefully help you with the remainder of the problems. So that being said, let's jump into it. So this first problem, let's do part A together. We want to know what is a reference angle if sine of x equals 8 over 17. And so just kind of doing some thought process here. When we're using x here, what we're saying is that this is a reference angle, but we don't know what it is. And so that's kind of the point of the problem is we have to kind of think of these sine, cosine, tangent as like an actual triangle. And so they're giving us a ratio of 8 over 17. Well, if you recall that the sine of x ratio is also the opposite over hypotenuse ratio, that means opposite over hypotenuse ratio has to literally be 8 over 17. And so if we take that thinking and we bring it back to this problem, okay, and we can even maybe enlarge that a little bit. Let's make that a little larger. Maybe. Here it goes. Okay. And so we take this back to this problem. What we're looking for is an angle whose opposite over hypotenuse ratio is 8 over 17. Well, if you note here that we have 8 over 17, 8 is here, 17 is here, we expect the hypotenuse to be 17, which tells us the opposite is 8. And so if the 8 sitting here on this side, we want the angle that's opposite from it, which is 28. And so the reference angle we're looking for has to be 28 degrees. There we go. And again, just kind of as a quick review on how we determine that, we first have to kind of realize a couple things. Sine of x still tells us a ratio of a triangle. The sine ratio, SOH, is going to be opposite over hypotenuse. That's something you got to commit to memory or be ready to have in notes. And since these both represent a triangle, this side being the reference triangle, and of course, this being the actual triangle, that means the ratio over h has to determine which pieces these are, the O being the 8, the H being the 17. And so on their actual triangle, we're looking for those two pieces, the opposite of an angle being 8, and of course hypotenuse being locked at 17. If we're looking at the 8, the only opposite side, or opposite angle, excuse me, is 28. Therefore, that has to be our reference triangle. Okay. B is very much in the same vein. This one throws a little wrench into it. We're actually wanting to find the cosine. Let's get a little closer here. We actually want to find the cosine of x, and again, this is our reference angle. Okay, there's a reference angle, but they're telling us that the tangent value of the same reference angle, and it's important to note, is that we're talking about the same angle, is 35 over 612. And so if we kind of recall, tangent defines a ratio, and that ratio is opposite over adjacent. That means 35 over 612 has to be opposite over adjacent. And locking it down piece by piece, that means the opposite has to be 35. And then the adjacent has to be 612. And so if we pop over here to our actual triangle, we can determine what angle that has to be. Opposite being 35, and so it has to be opposite of here. Okay, so that's the opposite. And then this side, 612, has to be the adjacent. Well, it's only one angle that does that, and that's going to be 3. That has 35 as the opposite and 612 as the adjacent. And so the reference angle has to be 3 degrees. Now, that's not the question, because the question asks us to find the cosine. But if we know the reference angle is 35 degrees, and we now take the cosine of 3, and this is not asking to look you up in a calculator. This is intended to be done without a calculator. So if we look at 3 as a reference angle, cosine, remind yourself, is A over H, which means this side has to be A over H for 3 degrees. And so if I look at our actual triangle using 3 as a reference point, the adjacent is 612, and the hypotenuse is 613. And so that's how we determine that we have the cosine value. By kind of keeping in our minds, a cosine is just a ratio of a triangle, and that's equal to another ratio on this side. And so we have 612 or 613 as our cosine value if our tangent value is 35 over 612. All right. We're going to skip part C, because I think that's a little straightforward. It's just asking you to call the ratios. And I want to talk about part E. So part E is a little bit weird. We want to sketch and label a triangle, a right triangle, of course, because all the trigonometry we've done so far is about right triangle, given only the fact that this angle, or I'm sorry, this statement is true. And so we have to acknowledge that we have this triangle, first of all. And I'm going to go ahead and draw that nice and big right here. So we have this right triangle, and we have this angle in it that's 22.620. Now, we're not concerned with two-scaleness here. We just want to represent a triangle the best we can, labeled properly. And so we know this angle because we have this angle here as the argument of the sine function. So we're taking the sine of this reference angle, 22.620. And so the question is, how do you find all the rest of the sides? Well, to find the rest of the sides, what we have to do is remember what the sine ratio is. And so the sine ratio being O, which means it's O over H, dictates that this over here is also O over H. And so if we know that 5 over 13 is O over H, that means the 5 has to be the opposite side to 22.620, and then the H, the 13 has to be the H to the same angle. And so coming back over here to our actual drawing, if we look at this 22.620, the opposite side has to be 5, so we'll label it as such, and the hypotenuse side has to be 13. And again, we're taking that right off what we know about the sine function itself, being opposite over hypotenuse, meaning that this ratio of this actual triangle has to fit those values. So we have 5 and 13. Now to find the last side, we could do a trig problem if we wanted to. Like we could actually try to find the adjacent side to 22.6, or we could use Pythagorean theorem, which I think is just as fast. And so if I know I'm trying to find this last side, call it the adjacent side, I know that a squared for adjacent has to be equal plus 5 squared has to be the same as 13 squared. And again, we're pulling those numbers right off this triangle or right off this sine function up here. And so there's our two values. So solving this down, we have a squared plus 25 is equal to 169. Okay. And so if I subtract 25 on both sides, I have a squared is equal to 144. Square rooting both sides, a's got to be the same as 12. Plus or minus 12 being the side of a triangle, we'll ignore the negative result and just have this being 12. So in the end, there's our triangle, fully labeled based only on the fact that we have the sine function equal to this ratio. Because in the end, sine, cosine, tangent, the numbers on your trig sheet, those always represent triangles, and so we can use them to our advantage as such. And that's what you'll see in the next section too, in part 3 of this key. I'll see you then.